Good morning. Today we are going to see operating system Unit 2 Session 14. In the previous topic, we have studied the concept priority scheduling using non-preemptive scheduling and preemptive scheduling. In today's topic, we'll study another scheduling algorithm, that is round-robin scheduling. So this scheduling is only based on preemptive scheduling, and in this algorithm, for every process, some specific time will be allocated, and when that time expires, the CPU will be taken away from that process and will be given to another process. And that another process will be given the same time for execution, and when the time expires, again the CPU will be taken away from that process and will be given to another process. So within this time, if the process completes its execution, then those processes will be not in the queue. If they don't complete the execution within that specific time, then again the processes will be sent back to the ready queue. Let us see. It is a preemptive scheduling. Time slice or time quantum is allocated to each process for execution. So as I told you, for every process some specific time will be allocated, and that time we call it as time slice or time quantum. When a process is executed for a given period of time, it is preempted and other process executes for a given period of time. So when the time expires, that CPU process will be taken away from the CPU and will be given to another process. Time slices are assigned to each process in equal portions and in circular order. So the definition of time slice or time quantum is the amount of time share given to each process, interrupting the job if it's not completed by them. Now let us see one example. So they are given the time slice, that is 2 units. So now every process will be given 2 units for execution. So to begin with, first consider the arrival time. So check out at 0th unit which process has arrived. At 0th unit, process P1 has arrived because this is the first process which has arrived in the queue. So allocate the CPU to process P1 and it has come with burst time 4. So now every process is going to execute for 2 units. So at the beginning, out of 4, process P1 is going to execute 2 units and remaining 2 units will be remaining. So process P1 is going to execute from 0 to 2 unit. So when process P1 is executing, check out if any other processes are in the queue now. Yes, process P2 and process P3 are in the queue now. So process P2 and process P3 are in the queue now. So when the process P1 finishes, when the time expires, it will come back in the queue now after the P3. And the CPU will be given to now next process, that is process P2, because this is first in the queue now. So the selection of the process will be in a first come, first serve manner. Will be in a first come, first serve manner. So you need to select the processes one by one from the queue. So now allocate the process P2. Now even the process P2 is going to execute for 2 units, that is 2 to 4. Now out of 5 it has executed 2 units, so still 3 units are remaining here. So now when process P2 is executing, check out which are the other processes are in the queue now. Yes, see till unit 4, process P4 has come now in the queue and process P5 has come in the queue now. So this is the queue. Now the CPU will be taken away from process 2. So now again P2 has not finished its full execution. So put the P2 to the queue again now. Now from the queue, which is the next process, P3. Now select P3. Now P3's burst time is 2 units. See. So, and every process is given 2 units only. So, P3 is going to complete its full execution. So, 4 plus 2 it is 6. And P2 has completed its full execution. So, it will be not sent back to the queue now. So, it will be not sent here now in this queue. So, now which is the next process in the queue now? And check out one more. See, when the process P3 was executing, another process has come here now. That is P6. So when process P3 was executing, another process has come, P6, and put that P6 in the queue now. Now as P3 has completed, now in the queue which is the next process? P1. So allocate the CPU for P1. So P1 out of 4 it has already executed 2 units, so still 2 units are remaining. So now it will complete. So 6 plus 2 it is 8. So now P1 will complete its full execution. So as this P1 has completed its full execution, don't send the P1 to the queue now. Now further there are no any other processes have arrived. When the P1 was executing, no any other further process has arrived. So now select another process from the queue, that is P4. Allocate it. So now P4 burst time is only 1 unit. So it will finish its full execution. So process P4 also you don't put in the queue now because it has finished its full execution. Now select another process from the queue, that is P5. Allocate the CPU P5. So P5 is going to take now 6 units. Now every process is given 2 units. So out of 6, it has completed 2 units means still 4 units are remaining here. So 9 plus 2 how much? 11. Now P5 has not finished its execution. So send it back to the queue now. Now which is the next process in the queue now? It is P2. So allocate the CPU to the process P2. Okay, P2 out of 5 it has already completed 2 units. So still 3 units were remaining. Now from 3 again it is going to complete 2 units. So 1 unit will be remaining here now. So 11 plus 2 it is 13. So P2 is going to execute from 11 to 13. Now as P2 has also not completed, so send P2 back again to the queue now, because it has not completed its execution. Now select next process from the queue, that is P6. So what is the burst time of P6? It is 3 units. So out of 3 it is going to execute 2 units. So 1 unit will be remaining. So 13 plus 2 it is 15. So as P6 has not completed its execution, so it will be sent to the queue now. P6. Now select next process P5. So P5 4 units are remaining. Now out of this 4 it is going to execute 2 units. So after executing 2 units, again 2 units will be remaining here. So 15 plus 2 it is 17. So as now P5 is also not completed its execution. So send P5 again to the queue. Still it has to complete its execution. Now in the queue, which is the next process? So it is based on first come first serve. So whichever process is in the queue, in that order only you need to select. So P2 still 1 unit was remaining. So now P2 is going to complete its full execution. 17 plus 1, 18. So P2 has finished its full execution. So then don't send P2 to the queue now. Now select the next process from the queue. It is P6. So P6 also, it need only 1 unit. So it is going to complete now. 18 plus 1, it is 19. So don't send P6 to the queue now because it has already completed. It has already completed. So now the last process which is remaining in the queue is P5. So P5 still it has to execute 2 units. So it will complete its full execution. Even if here some more burst time is there. See now, first of all, see, it will complete its execution. So 19 plus 2, it is 21. Okay, now P5 is the last process. Now further there are no any other process. So P5, even if there are more units left for execution, then at the end it has to complete its full execution. So this queue is important here. So however the process comes, we need to put those processes in the queue now. So if the processes are incomplete within the 2 units, if they have not completed, we need to send them back to the queue again. So that is very important. So this is the table, process number, arrival time, burst time, then find out the completion time of the processes. P1 completion time is 8, P2 completion time is 18, and P3 completion time is 6, P4 completion time is 9, and so on. So like this way you need to find the completion time of all the processes and note down here. Then find out completion time minus arrival time. Completion time minus arrival time, consider these columns. Then you will get these values. Then find out waiting time, that is turnaround time column minus burst time. You will get these values. Next, find out the turnaround time average. So consider these values to find out average of turnaround time. Consider these values to find out average of waiting time. Now next example we'll see. Now they are given here the time slice 3 units. So every process has to execute for 3 units. So first consider the arrival time. Check out at 0th unit which process has arrived. So at 0th unit none of the process has arrived. So CPU is going to remain idle from 0 to 1 unit. None of the process has arrived. So check out at unit 1 which process has arrived. Process P4 has arrived. So this is the first process which has arrived in the queue. So allocate the CPU for the first process. And as I told you, it is going to execute for 3 units. So 1 plus 3, it is going to be 4. So process P4 is going to execute from 1 to 4. Now check out when process P4 is executing, which of the processes has arrived in the queue. So at unit 2, process P5 has arrived. So write that in the queue. And at unit 3, process P3 has arrived. And at unit 4, process P2 has arrived. Now, process P4 is going to execute. Its burst time is 9. So, it has executed 3 units. So, remaining still 6 units are remaining here. So, take the CPU from process P4 and send it to the queue now. So P4 will be put up into the queue now. Now from the list, which is the first process, select that, first come first serve. So allocate the CPU for process P5. P5 is also going to execute for 3 units. Now its burst time is only 2 units. So 4 plus 2, it is going to be 6. Now check out when process P5 is executing. From 4 to 6, which of the other processes has arrived in the queue? So at unit 5, process P1 has arrived. And at unit 6, process P6 has arrived. Now, P5 has already finished its execution. So don't put this P5 into the queue now. So P5 has finished its full execution. Remove it from the list. Now allocate the next process, which is the next process in the queue, process P3. So allocate the process P3. So P3 is going to execute, its burst time is 7. P3 is going to execute for 3 units. So out of 7, if it completes 3 units, so remaining there are 4 units. So 6 plus 3, it is going to be 9. Now check out when process P3 is executing, which of the other processes has arrived in the queue. So there are no any other further processes has arrived in the queue now. So process has stopped arriving. So now check out whether the P3 has completed. P3 has not completed its execution. Still 4 units are remaining. So put the P3 into the queue now. Now select the next process from the queue, that is process P2. So allocate the process P2. So what is the burst time of process P2? 6 units. So out of 6, 3 units it is going to execute and still 3 units are going to remain. So 9 plus 3, here it is 12. So P2 is going to execute from 9 to 12. Check out whether the P2 completed its full execution. P2 has not completed its full execution. Still 3 units are remaining. So put P2 into the queue now. Now allocate the next process P4. P4 is going to execute now till 3 units. P4 burst time is 6 units. So out of 6, 3 units it is going to execute and still 3 units are going to remain. So here 12 plus 3, it is going to be 15. So P4 has not completed its full execution. So put P4 into the queue now. It has not completed full execution. So select the next process from the queue. It is P1. So allocate the process P1. So P1 burst time is 5 here. So out of 5, it is going to execute now 3 units. And still 2 units are going to remain here. So 15 plus 3, it is going to be 18. Now P1 has not completed its full execution. Still 2 units are remaining. Put P1 into the queue now. Now next process which you are going to select is P6. So allocate the process P6 to the CPU. Now P6 is going to take 3 units here. Only 3 units. So it is going to complete its full execution. So 18 plus 3, it is going to be 21. Now P6 has completed its full execution. So don't put this P6 into the queue now. So don't put P6 into the queue now. It has finished its full execution. So next process you select from the queue, that is process P3. So P3 burst time is still 4 units are remaining. So out of 4 it is going to execute 3 units. So still 1 unit will remain. So 21 plus 3 it is 24. So P3 has not completed its execution. So put P3 into the queue now. Still 1 unit is remaining. Now select the next process from the queue, that is process P2. Allocate it. Check out the burst time of process P2. Yes, process P2, it is going to execute 3 units. So 24 plus 3, it is going to be 27. So all 3 units it has completed. So P2 has completed its full execution. So don't put into the queue now. Now select the next process from the queue. It is P4. So allocate the P4 process. Check out the burst time of process P4. Still 3 units are remaining. So it is going to complete its execution. 27 plus 3, it is 30. So P4 has completed its full execution. So don't put P4 into the queue now. So next, select next process from the queue. It is P1. So P1 burst time, still it is 2 units remaining. So it is going to complete full execution. So don't put P1 into the queue now because it has finished its full execution. Now the last process from the queue which is remaining is process P3. So allocate the process P3 and still only one unit is remaining here. So 32 plus 1 it is 33. So this queue is very important here. So you need to form the queue very carefully here. So whenever any particular process is executing, check out if any other new processes are in the queue. And before taking the CPU from the process, check out whether that process has finished its execution or no. If it has not finished its execution, put back that process into the queue. And if it has finished its execution, then no need to put up into the queue now. Just remove the process from the list and you can continue with the further. So this is the table. They are given the process number, arrival time, burst time and the completion time. So find out the completion time in the same way. So completion time of process P1 is 32. Process P2 completion time is 27. Process P3 completion time is 33. Check out here, see. Process P1 completion time is 32 and process P2 completion time is 27 and process P3 completion time is 33 and so on. So find out the turnaround time, completion time minus arrival time. We'll get these values. Find out the average time, turnaround time minus burst time. You will get these values. So find out the average turnaround time by calculating this. You will get here 21.3. Find out the average turnaround time by adding this. You will get here 16. And there is another column, response time. As I told you in the previous example, it is a allotted time, process allotted time minus arrival time. So when was the first process was allotted, that time you need to consider. So the process P1, it is 10. So what was the allotted time of process P1? Check out. So when was the first process, when was the first CPU was allotted to the process P1? You can check here. We have here processes. P1 was allotted at the time 15 and its arrival time is, see how much? 5. So it is 15 minus 10. Allotted time minus arrival time, it is going to be 10. So as we have got here 10 value. So remaining you find out in this way. So here we have finished round robin scheduling algorithm. Thank you.